Now that you know about different kinds of compounds, we're going to start talking about how to name compounds. This again is part of the vocabulary that we're getting used to. We're going to start by looking specifically at the molecular compounds. And when we look at molecular compounds, we have some pretty complicated naming rules. So we're not going to get into most of the details. And I just want to let you know that we're not going to talk about organic molecules in this class because you're going to have a whole class on them next year. So I'm just not including those. And we are going to stick with just 2 elements per compound. We're going to call these binary compounds, and these are specifically binary molecular compounds. So that means that these binary molecular compounds are going to consist of all nonmetals, or potentially maybe a semi-metal. So I'm going to include the naming conventions that are standard for naming binary molecular compounds, and I'm pretty sure you probably already know about a few of them. So one thing that I do want to clarify is that when we talk about these binary molecular compounds, there's going to be 2 elements as a maximum, and it's by definition going to have 2, but we can have more than 2 atoms in a compound. So you can have more than one of each of your 2 elements. So let's look at a couple of examples. Let's think about this compound that you probably already know. Okay, you probably already know what this one is called. Notice that it has 2 elements, and that they have also this additional detail of a number right here. So what do these numbers mean and what do these letters mean? So you probably already know this, but I'm going to go through it anyway. Each of these elements here has its elemental symbol, so we can recognize that this first element is carbon and the second element is oxygen. And the 2 here means that there are 2 oxygen atoms. And although there isn't a 1 right here, because we never put in if there's just a 1, that is the implicit understanding that we have. So we have 1 carbon atom and we have 2 oxygen atoms. The number will always come after the element, the number that is referring to that element. Okay? So if you remember that this is called carbon dioxide, just because you've seen it before, a lot of people talk about it, especially when they talk about global warming and stuff like that. So we talk about carbon dioxide. So this name is probably already familiar. And I want to talk about another example here really quick that you may also be familiar with before we talk about the rules in general for naming them. So carbon dioxide, it has a chemical formula that is CO2. And you can see the hints for this name, right? Here's carbon, and then here's dioxide, indicating perhaps that we have these 2 oxygens here. So carbon dioxide has a cousin compound that you may also have heard of, carbon monoxide. It's a toxic gas, and this is its chemical formula. So notice here we still have the carbon, we still have the oxygen, but we don't have any numbers here indicating that there's 1 carbon and 1 oxygen. So look at the name. Look at the difference between these 2 names. They start the same, carbon, and look, there's one carbon. But this time there's monoxide instead of dioxide. So I think you can identify here that this di is going to be related to that 2, and the mon is related to the fact that there's only 1. And so when we talk about naming these compounds, we have some naming rules. So I'm going to summarize what we've seen so far, which is with this first element, we just name it. And we're going to have a slight modification here if we have more than one of that first element. So I'll just put that note here. Most commonly, we'll end up with just one element of those first. So we're just going to name it if there's just one of that atom. So here's for our first element out of 2. For our second element, notice that we did 2 things. Do you see what they are? Remember that we talked about this element name. It was oxygen, and then it got turned into oxide. So we're going to change the ending of the second element to end in "ide." So let's look at a couple of examples here. Oxygen became oxide. What if we had nitrogen? Why don't you guess? It should be nitride. Let's try carbon. Carbide. How about sulfur? Sulfide. Hydrogen is always a little tricky one. It doesn't show up in the second position very often, but occasionally it does. And it's going to turn into hydride. Okay, so I think this is probably enough examples that you should be able to generalize from here. So this was the first part of what we do with the second element. So maybe I'll say part A. And then part B is we add a prefix to indicate the number of that second element. So let's go over to the book and take a look at the table showing all those prefixes. Okay, so here we are. This is table 2.2 in our book. And you can see that when we have, in this table, we have up to 10 elements in our compound that we're able to name. So we've already seen 1, which added a prefix of mono. 2 is di, 3 is tri, and then we go tetra, penta, hexa, hepta, octa, nona, deca. So these should be reasonably familiar if you've ever had Greek and Latin roots that you studied in class earlier. And they also mimic things like pentagon, hexagon, etc. So they should not be totally unfamiliar to you. Now, I will not expect you to know all 10 of these, but it is a good idea to at least go up to 5. And we will occasionally see compounds that have more than 5 of an element in there. So being at least reasonably familiar or able to figure out what these prefixes are when you see it in a name is going to be a good plan. So let's go ahead and try a couple of some practice problems here. And I also want to have a little caveat here for our first element, which is when there's more than one of the first element, we add a prefix to it. So you can have a prefix on both of them if there is more than one of that first element. Okay, so let's look at some examples. I'm going to write some up here and you can give them a try. So let's try SO2, N2O, PCl3, SF5, NH3. Pause the video and give these a try, and then we'll check and make sure that you've got the right names on them. All right, hopefully you paused and you took a chance to try these out yourself. So if you identified this first one as sulfur dioxide, that's correct. This is the only one with 2 in the first place here. So hopefully you named this as dinitrogen monoxide. Notice that even though the prefix here is mono for 1, when we add it to oxide, we just drop one of the O's and turn it into monoxide. This next one is phosphorus trichloride. D would be sulfur pentafluoride. And this last one would be nitrogen trihydride. Now, you might have noticed that some of these compounds also have a common name. Like this last one here, you might also be familiar with it as ammonia. And this one here actually too is also called nitrous oxide or just nitrous. It's that gas that sometimes people have when they go to the dentist. And of course then there is a fifth example, which is this one, right? And probably if you have named this before, you can recognize it as dihydrogen monoxide. But this has a common name too, which hopefully you remember is water. And you've probably seen some of those spoof posts about the dangers of dihydrogen monoxide. And this is, of course, one of those things that people are just, I don't know, they're making fun of if people don't know chemical names, that they're always afraid of them. So, number one, don't be afraid of something just because it's a chemical name. And number two, figure out what all the details are before you spread misinformation. Anyhow, so all of these common names that I put in here, these are probably what we are going to use if we're just talking about something in lab. We may very well use the common name. But when I ask you to name a binary molecular compound, I do want these formal names, even if it's something very common like water. You can write both names in, and that's totally fine, but you do need to make sure that you're able to name the binary compound using these formal naming procedures.